Hello and welcome back to the Coking.com channel. I'm here in Germany with our friends at Berthold. I'm here with Heike Mann and Stefan Mueller. Want to introduce yourselves briefly?
Yeah, thank you for coming. And Evan, so I'm Heike Mann, working for Berthold since 28 years. I'm head of product management and technical sales department, and happy to have you here, Evan.
Thank you. And Stefan?
Yeah, my name is Stefan Mueller. I'm the head of the HSE department at Berthold, and I'm with Berthold for 13 years now.
Welcome, welcome. Well, so today we're going to be talking about something relatively unique. So in most of the applications for nuclear level instrumentation, we're familiar with the point source continuous level detectors. But today we're going to be talking about the rod source and the point detector. So we're going to start with Heike first, and tell us a little bit why somebody would choose this over this.
Yeah, using a rod source compared to a rod detector in a level arrangement has several benefits. One of it is you get a much more linear curve, which provides you higher accuracy on your level height, as well as we can overcome with internal build-ins by adjusting the pitch of the cobalt rod source. So the activity distribution along the rod will be adjusted according to the vessel design exactly. And furthermore, we can react much more faster to level changes. Mm-hmm. If you have fast level changes, then such a measurement will react much faster. And as an additional nice benefit, in case of NDT, using a point detector with a rod source is much less susceptible. Susceptible.
She's doing well. She's German speaking.
Yeah, that's I do not like that word, susceptible.
There you go.
Here we go. Yeah, so it's less susceptible for NDT events. So you can measure continuously still when an NDT event occurs, because the point detector most probably will not even recognize such NDT event.
Yeah, so that's actually why I came to know about this technology, because as many of you know, in Coker world, we have the gamma levels either on the main fractionator, typically sometimes on the blowdown tower, and there's some facilities that we work with, especially in the U.S. Gulf Coast or areas that are highly industrial. Mm-hmm. NDT is happening all the time, right? And one of the things that can happen is that you're going to check out probably our separate video on the X-ray protection built into this technology for the coke drums in general. But what happens is when that X-ray detection is felt by the detector, it just sort of locks the signal in place. And until that external radiation source goes away, it just stays put. And one of the things that can happen is that the level can change dramatically during that time period, and the operator at the control room has no idea. So for certain applications, this technology kind of makes sense for the main fractionator application if you're really concerned about making sure that that NDT protection is robust.
Absolutely.
Robust. So maybe some of the speeds and the linearization is not quite a huge issue for us in Coker world, but for other applications and industrial purposes, it makes a lot of sense. So
absolutely, yeah.
Thanks for that background, Heike.
You're welcome.
I'm going to bring Stefan in next, and he's going to share with us exactly how these things work and how they're made. So, Stefan, tell us, please.
Our technical sales and engineering department, they are taking care to do the calculation according to the customer's vessel that he needs continuous level measurement for. And then we have the possibility to produce these cobalt-60 rod sources in-house in our own production. And actually we have a rod inside this source capsule. Maybe we could
there we go.
Open this one. Yeah. It doesn't want to.
So while Stefan's fighting with that other rod, I would just point out that there's actually a little rod in here. We'll get some close-ups on this. and there's a little tiny wire wound around this rod. And we have a little bit of that wire kicking around up. Heikki has it hiding for us. So this is cobalt wire, and it is made radioactive how?
We sent these inactive cobalt 59 coils to research reactors which we're cooperating with, and then these cobalt 59 coils are activated in the research reactor to cobalt 60, and we get back the radioactive material, the cobalt 60, and then can produce the cobalt 60 sources.
So it never ceases to amaze me. Just like in the point source, there's a little tiny piece of radioactive material in this capsule, and there's this tiny little wire that does all the radiation that we need it for.
Correct.
So what do you got there, Stefan?
Yeah, this is the inner rod where the radioactive cobalt 60 wire is winded according to the calculations the technical sales department came up with.
Well, so let's touch on that for a second. So Heikki mentioned that you linearize this.
Correct.
And that linearization process has something to do with how you actually wind the wire, right?
Correct. The closer the windings to each other, the higher the activity in the segment of the cobalt 60 rod source. And by using this kind of technology, we could take care that the customer gets a direct proportional signal for the radiation, which how to say?
So if there's like there's a man way in the way, or there's a thermal well or something that's in the way of this radiation source, you just add a few extra wraps.
Correct.
In that zone to give it a little bit more juice to push through the metal.
Yeah.
So that you get, I mean, that's juice, that's a technical term, right?
Yeah. Just a little bit more power.
A little bit more power. There you go.
The higher activity at this segment, and then you have a higher radiation intensity, which then can push through the material.
Okay.
Yeah. And
Perfect.
we can also take into account the inverse square law to achieve a linear signal over the whole measuring span.
And this is important for those applications. You need precision, right? You know, plus or minus a very small window, which is not possible with the point source style configuration.
Yeah. If you are using the point source, then you have to take care to do this linearization by taking measurements over the measuring span and do the calculation.
Mm-hmm.
Yeah. And by using the rod detector, you can get rid of this because we are taking care of the linearization.
Interesting.
Yeah.
So there you have the rod, and we've talked about the wire. Anything more on this point?
Yeah, then it's comparable to the point sources. We are winding the wire. Then putting the capsule together, welding both sides of the capsule, do the contamination testing, leakage testing, and then it's ready to enter the shield. And here we have an example for rotatable rod source shield, which is typically used for the level measurements, and usually the measuring ranges are up to 3 meters.
So this feels like about a meter.
Yeah.
So this source would go more or less in here.
Yeah.
And then
Center in here.
Yeah.
And then you would, if you need a larger measuring range, then you would add additional shields on top.
Sure, for sure. So you could go much more than 3 meters, but that's more or less where you in one single rod, range. You can go 3 meters.
We can produce one rod with a length of up to 1.2 meters.
Okay.
Yeah.
And then, so this is very similar to this guy that we saw in the other video about, the shield. And
the function of the shield is comparable to the shields that you used, at your coke drum.
And it also has a collimator on it. Is it on the source side or is it on the detector side in this application?
No, you have a collimator in here, which is just a slit along the side of this cylinder.
Okay, interesting. Well, I think this is very interesting. like I said at the top, this is an application that has many uses across a variety of different industrial applications. But for us in the delayed coker land, we're really keen on the aspect that it's very protective against external NDT interference, and it's also can be very fast. So for those of you who have applications in your fractionator where you want it to be super accurate and you want to really know where everything is, this is something to check out. It was relatively new technology to me a few years ago, so I really want to thank our friends at Berthold for giving us a rundown about how this works. And thank you for visiting the video. Thank you, Heike and Stefan.
Our
Excellent
pleasure.
education. So thanks for watching, and enjoy the rest of the Coking.com YouTube series. Thank you.